Hello and welcome to the second of our lessons on moles, and we're going to be looking at using the equation. Okay, so this is the equation triangle that we use. There's lots of m's and mass and molar mass and moles. It's all very confusing, so we need to be really sure that we know which one we're talking about. So when we're looking at a question, will often give a mass in grams, and that's going to be that top number. So the actual physical mass, the weight, if you will. I know it's the wrong word, but bear with me, of the chemical we're working with. The MR is our relative molecular mass. So that's the one that we find on the periodic table. And they've used N here for amount in moles. I don't really like that because where's the N coming from? To my mind, it makes more sense if we said that was the number of moles, but that box there is the moles. How are you going to remember that? Well, you might just remember that if it helps, Mr. Mole lives under a massive hill. Okay, so Mr. MR Mole in that bottom right lives under a massive hill, the mass being at the top. That might help remember which one goes where. I would say that this is the core concept for this lesson. Everything we do from now on is going to be based around this triangle. Okay, so here's the triangle again, just looking a little bit different. Mr. Mole is under a massive hill. So you are absolutely going to need to be able to manipulate this equation, and sometimes you're going to be asked to calculate mass, sometimes you're going to be asked to calculate the molecular mass or the formula mass, and sometimes you're going to be asked to calculate the moles. So how do we do that? Well, you should know by now, if I wanted to calculate moles, I would put my hand over that there, over the one I'm looking for, and that's mass divided by molecular mass, and that is my calculation there. Number of moles is mass divided by molecular mass. Okay, can you get there before I can? I want to calculate the mass. So which one am I using? I'm going to go for the top one. I'm going to cover it up with my hand, and that is the molecular mass times number of moles. There we go. Did you get there first? Okay, and finally, if I wanted to calculate the molecular mass or the formula mass or the atomic mass, if it's just an element or an atom, I'm going to cover up that one there, and it's going to be mass divided by mole. What they often like to do is do this for an element, and then you would look at the periodic table and you would find out which element that you've discovered. So they'll say substance X is an element on the periodic table. You find the atomic mass, and then you figure out which element you've got. Okay, so typically the complaint when it comes to exam questions is you get this sentence with all these numbers in it and you're not quite sure what you're looking for. So let's look at this worked example and see if we can figure it out. If you're already quite comfortable and feeling confident, you might pause the video and have a go yourself, but I am going to do this intentionally with you rather than afterwards. Okay, so let's read this question. I've got my core concept there. Right, so it says I have a mass of 0.5 grams magnesium oxide in 100 centimeters cubed of hydrochloric acid. Calculate the number of moles in 0.5 grams magnesium oxide MgO. So my command word there is calculate, which means I'm going to be using my calculator, and I would suggest you always write down the formula first. You never know if it's going to pick you up any marks, but it will also guide your calculations through, so you're constantly referring back to that calculation. Have I done it in the correct order? Are my numbers the right way around? I would always write the formula out. Okay, so what am I calculating? Which one am I looking at? It says I'm calculating the number of moles. Okay, so I'm going to go to my triangle. Nothing wrong with you writing this out in the exam. Absolutely do it if it helps. I'm going to cover that one up, and then for my formula is going to be number of moles equals the mass divided by the molecular mass. Okay, so now I know what I need to do. I need to find those numbers. So I've got some numbers going on here. I've got this number here. I've got this number here. I've got the 0.5 grams again, but it's still magnesium oxide, so I'm not going to worry about that. Right, okay, do I have a mass? Yes, I do. I have a mass. It says here I have a mass of 0.5 grams magnesium oxide. Okay, it says grams, so I'm happy that that's the right one. Okay, 0.5 grams. Right, good. Right, do I have a molecular mass? No. What's that 100 centimeters cubed? Well, nothing's in 100 centimeters cubed in this formula. They've just tried to confuse me. Okay, I don't have molecular mass. Could I work out molecular mass? Well, molecular mass is the periodic table stuff. It's a formula mass, adding stuff together. Oh, hang on a second. I've got MgO there. That's a formula. Right, I need to look at my periodic table. I've got Mg, I've got O, so that's 24 adding to the 15.999. Okay, that's going to be 40.304. Okay, I've got those two numbers. I can do the calculation. I have 0.012 moles of magnesium oxide. Job's a good one. Okay, your turn. Pause the video and have a go yourself. Use core concept for support, and just be aware that number 4, there's a couple of stages there. Remember your ratios with both sides of the equation. Okay, so number 1, how many moles are there in 66 grams of CO2? I'm looking at my equation. It's going to be mass divided by molecular mass. Do I have a mass? Yes, 66 grams. Do I have a molecular mass? No, but I can work it out. 1 carbon, 2 oxygens. So that's going to be 44.009, giving you the answer 1.5 moles. Okay. What is the mass of water in 0.75 moles? Okay, so the mass this time, that top one, it's going to be molecular mass times moles. So have I got a molecular mass? No. But I can work it out because it's water, H2O, so that's going to be 18, isn't it, thereabouts, times 0.75, giving you 13.5. Now you'll notice with that one, you're not given a formula for water. You would be expected to know the formula for water, so you know, don't let it fool you. Certain formula you need to know: water, carbon dioxide, you would need to know hydrogen is H2, oxygen is O2, and that's about it really. Okay, so question 3. What is the formula mass of substance X if there are 0.112 moles and 6.25 grams mass? Okay, identify the element. Okay, so this is what I was talking about earlier. So with the formula mass of X, I'm guessing that really should be atomic mass because it says identify the element, but never mind. Right, so formula mass is R. Do I have a mass? Yes, 6.25. Do I have an amount in moles? Yes, 0.112. So I'm going to do that calculation to get 55.8. And if I look on my periodic table, I would identify that as iron. Now, if you don't have a periodic table in front of you, don't worry. It would have been iron because iron is the only element with an atomic mass of 55.8. Okay, number 4, I'm going to go on to the next slide because it's a little bit bigger. Okay, so question 4, consider the balanced equation below, which means I'm going to have to use that equation. It gives me the mass of X, it gives me the mass of copper, and my command word is calculate. So I'm going to use calculator and I'm going to write down my equation so I might pick up those marks. I'm definitely going to not lose my place. What am I calculating? The atomic mass. So that is going to be the MR. Okay, be careful there, the MR, not the M, okay, and identify the element, right, okay, so if it's the MR, it's going to be mass divided by moles, okay, sorry, that was my book closing, right, what information do I have? Do I have a mass of X? Yes, I have 19.12 grams, lovely, okay, do I have moles? No. Can I work out moles? No. Problem. Okay, what on earth am I going to do? Right, well, and this is where you need to remember, okay, let's look at that equation. Okay, what other information have I got? I've got the mass of copper. Okay, I've got the mass of copper, and I know that looking at that, I've got copper and X. I've got a 1-to-1 ratio of the X and the copper, haven't I? Can you see that? So the X on one side makes 1 of X makes 1 of copper. So I've got a 1-to-1 ratio. Okay, could I work out the moles of copper? Because if it's a 1-to-1 ratio, if I know how many moles of copper I've got, I can say, well, I've got the same amount of X. Okay, right, well, if I wanted to work out moles, that's going to be, look at my formula, look at my triangle, mass divided by molecular mass. Okay, do I have a mass? Yes, I do, 50. Do I have a molecular mass? Yes, I've got that number there from the periodic table. Oh, look at that, I've got the number of moles. That's the number of moles for copper, 0.787. Now this is important, my ratio is 1-to-1, which means I can go back and plug that number in to my original formula. So I have got 0.787 moles there too. Now I can work out my atomic mass, 24.29. And if I look at my periodic table, the closest I get there is magnesium. Now this is because I've made up this question. Our reality is the exam would be a little bit more spot on than that, but you get the idea. Right, guys, that is it for this video. I hope that's been helpful. We're going to move on a little bit more and look at some more of these calculations where we're using both sides of the equation.